Hello, in this video, I will walk you through my machine learning assignment where I compared two popular classification algorithms, KNN and decision tree, for image classification. I tested them on two datasets, Fashion MNIST and CIFAR-10, and also explored model tuning to improve accuracy. So let's get started. I started by importing libraries like NumPy, Matplotlib, Seaborn, Scikit-learn, and TensorFlow. These provided the tools for data loading, pre-processing, model training, evaluation, and plotting. I loaded the Fashion MNIST and CIFAR-10 datasets directly from TensorFlow. These datasets include labeled images that are widely used for benchmarking image classification tasks. For the Fashion MNIST dataset, I reshaped the images into one-dimensional arrays and normalized them by dividing by 255, which is the pixel values. Since KNN is a distance-based algorithm, I used standard scaler to scale the features for better performance. Next, I trained the KNN model using 5 neighbors and predicted the test labels. The accuracy achieved was just above 85%, which is quite good. The classification report showed strong precision and recall values for most classes. The confusion matrix also looked very clean, with most predictions correctly along the diagonal, showing the KNN performed well on this dataset. Then I applied the decision tree model to the same Fashion MNIST dataset. I set the maximum depth to 20 and used the entropy criteria. The model achieved around 79%, more than 79% accuracy exactly. It performed well on some classes like trousers and ankle boots, but was less consistent compared to KNN. The confusion matrix showed more scattered misclassifications, especially between visually similar items. Next, I moved on to the CIFAR-10 dataset. This one is more challenging because it contains colored images of real world objects. I again scaled the data and trained a KNN model. The accuracy here dropped to the 27.45, which is expected for basic KNN on such a complex dataset. The classification report showed that most classes had low precision and recall, and the confusion matrix was scattered with many wrong predictions. I also applied the decision tree model on CIFAR-10. The initial accuracy was around 25.68%, slightly lower than KNN. Again, due to the complexity of the images, the tree struggled to generalize and made many incorrect predictions. This highlighted the limitations of using decision tree for high dimensional image data. I then plotted a bar chart comparing all four models, KNN and DT, on both datasets before any tuning. KNN outperformed DT on both the datasets. Fashion MNIST gave higher scores than CIFAR-10 overall, showing that grayscale images are easier to classify than colored ones for these algorithms. Then, to improve the performance, I tuned the KNN model by testing values of K from 1 to 10. For Fashion MNIST, the best accuracy of 85.43% was achieved at the K is equal to 4, just slightly better than before. For CIFAR-10, tuning improved the accuracy slightly from 27 to 28% at K is equal to 5. So even though KNN is limited here, tuning helped a bit. I also tuned the decision tree by trying different combinations of max depth and splitting criteria, Gini and entropy. For Fashion MNIST, the best accuracy was 81%. with depth 10 and entropy. For CIFAR-10, tuning gave a small improvement, uh, raising accuracy to 20 around 29% is accurate, 28.96% with depth 10 and Guinea. Finally, I plotted the before and after accuracy for all models. KNN remained strong on Fashion MNIST, and decision tree caught up slightly after tuning, around 1%. For CIFAR-10, both models improved 1 to 3%, but stayed under 30%, confirming that more advanced models or feature extraction would be needed for such complex data. We can say that KNN performed better than the decision tree on both the datasets, especially on Fashion MNIST. Decision trees are faster and more interpretable, but they struggle with visual complexity. Tuning helped both models through improvements, though improvements were modest. For simple grayscale data, KNN works well out of the box. For more advanced datasets like CIFAR-10, other techniques like CNN or ensemble models might be more appropriate. Okay, so thank you. Thank you for watching.